Welcome to Maths with EJD. We continue with data analysis with Python. Since our focus is on data analysis, with Python in particular, we need to consider Pandas at this point, which is like the key Python library for data analysis. So, uh, introduction to Pandas. Pandas is an open source Python library used for data analysis and manipulation. So anything about data cleaning, data cleaning, uh, data pre-processing, data manipulation, data analysis, and all of that. Pandas is your go-to library in Python for that. So it provides powerful, flexible data structures that make working with structured data like spreadsheets, SQL tables, and CSV files both easy and efficient. In the previous video, I talked about types of data to be structured and unstructured. With structure being the type of data that will be arranged in rows and columns, and you can easily address them, using the rows and columns. So the name pandas actually comes from panel data. Pandas, panel data, a term used in econometrics for multidimensional structured data sets. Okay, so with pandas, you can load, clean, transform, analyze, and export data, making it an essential tool in data science, machine learning, and finance. So you can get an external data and use pandas to work on it. And then whatever your result is, you can now export it back. So you can import data and export it back into the forms we had seen before, like CSV, Excel, JSON, and so on and so forth. So interestingly, before videos 2 to 13, I think part of the videos 2 to 13, maybe starting from like 8 to 13 or 9 to 13, we talked about NumPy, which is for things like broadcasting and working with arrays, basically. So Pandas is built on top of NumPy and and integrates well with other data-centric Python libraries like Matplotlib, Seaborn, and scikit-learn. So I mean, scikit-learn, when you go to scikit-learn, you're already beginning to talk about machine learning, data science, machine learning, like that. So Pandas introduces two powerful objects or data structures. Powerful indeed. You have like a series, which is one dimensional, like a list or a column, right? So if you have a list, like what we saw, the kind of inbuilt Python data type and Python structure, data structure like list. So that's what a series looks like. But then we have something more powerful, which is two-dimensional, and that is a data frame. So most of the times you see DF, that DF we use in Pandas, it basically is what is obtained from this data frame. So it's two-dimensional like an Excel sheet or SQL table where you have rows and columns. So Pandas enables fast and efficient data wrangling. It also helps in importing and exporting data, like I said, from various formats. So you can import from CSV, Excel, SQL, TSV, JSON, and of you can import from them and then export back to them. We imported from them in the last video. We are also going to do that here. But now we are going to export by the time we are done with whatever we need to do. Okay, so now in number three now, filtering, aggregating, cleaning, reshaping, and visualizing data is another thing that Pandas can help us do, and we're going to see all of that. All right, so let's talk about Pandas objects. Pandas objects. The first, I mean, we've established already that the key objects of Pandas are series and data frame. So let's look into those. So a series is simply a one-dimensional labeled array that can hold any data type, like integers, strings, floats, or Python objects. So to create a series, now to use Pandas, right? In fact, let me say to use Pandas before we even talk about creating a series because this is really key. So you have to install pandas using pip. I think that must have been taken care of in previous videos. So pip install pandas. That's how to install pandas. I guess it's important to emphasize that idea here. Okay. Let me go for that. Okay. This um create cell above. So I have this now. So uh installing, let's start with installing Pandas. How do you install Pandas? Of course, I have it installed already, but I just want to be sure that nobody is watching this and does not know how to go about this. So to install Pandas, you just need to install any library in Python. Mostly, you just need to use pip install, then the the library, pip install pandas. So if I click this now, it's going to take a bit of time and then tell me I already have it. Okay, so it says requirement already satisfied. But if you're just doing it for the first time, then it will install it. Maybe it will take a bit more time. So that's the first thing. You install pandas. Then the next thing is you want to import to be able to use pandas, right? You need to import it, right? So I put this here and I say importing pandas. So if you don't import pandas, you won't be able to use it. So importing pandas. So this has to be markdown, right? Don't forget, code is for code. If you need to run a code, markdown is when you're typing, like maybe a heading or an equation, and raw is if you just want what you have there to be just the way it is. So to import pandas, all you need to do is bring in this line. So you import. So you could just say import pandas without anything extra, okay? But because anything you have to do subsequently, you have to keep writing pandas dot that pandas dot everything. Like all this PD, you see PD dot series. Without the PD, it won't work. So it's better to now import it as an alias, which is shorter, and that's usually PD. You can call it PN, you can call it PA, you can call it PS. Anything you call it is fine. But PD is like the conventional thing we use most of the times. So once you run this importation, right, you don't have to. So that one importation is will carry you through anytime as far as in this session, as far as you have run this. So if you don't run this and you want to do something else, for instance, let me clear this whole thing. Let me just say restart kernel and clear output of all cells, right? If I do this now, so everything is cleared now. So now I have not imported. Then I just go straight here to I want to create a series, and the import thing is not up here. So it's up here without being done. So if I run this, it's going to give me an error message. It tells me that name PD is not defined. So that simply means that I have not imported pandas here as PD. Okay. So now that that has been done, once you see this number here, so anytime you run a cell and a number shows up here, it means it's done. If it's not done, it should show you like a star still working until once it's done, a number is outputted. So here now that I've imported pandas, then I can now create a series. And the easy way to create a series is you can create basic series from a list. And a list is a Python, it's a Python inbuilt Python data structure. We've dealt with that a lot when we're talking about general ideas about Python. So I have my series and I call it, so this S is the series, the variable name S, and it's pd.series. Then I use this series of this list of 10, 20, and 30 to create now a Python series. So once I run this, then I print it in line 3, and so it shows me. Now, one thing about Python pandas now is that you now have index. You now have an index. In the normal Python, in the normal inbuilt Python data list, it just lists the numbers. It doesn't give you the numbering. So here you now have an index, and Python counts from 0 upwards. So that's why we have this like this. So we have created the series. Now, one thing you can do is if you don't want the counting to start from 0, like that, you want it to start from 1 to 3, or you want it to start from ABC or anything you like, you can do that. So you can customize the index. So I think I should put this in bold. And to put this in bold, I just do this double star in front, double star behind. That's a Jupyter notebook thing I just run. And then you can customize the index. And to customize the index, instead of just saying s equals pd.series 10, 20, 30, you now have index to be ABC. So if you print this now, so instead of 0, 1, 2, you now have ABC here. You can also you can still do the same for can still do the same for, say, maybe we want it to be 1, 2, 3, okay? And it now takes 1, 2, 3. You can also make it in Roman numerals, right? You have this. So for Roman numerals, say you want 1, 2, 3 like this. That also works, okay? So anyhow you want it, you can get it. So you can customize the index. Now, I mean, this is easy because we know we have just 3 elements. What if you have 1,000? So that's another issue. So as we go further down, I'm going to talk about that. So you can actually access elements from this S now. Okay, okay, the last S we have is this 1, 2, 3 now. So I may not be able to use this. So if I run this now, it's going to give me an error most likely because the last S that we have, because it reckons with the most recent S. So since I was interested in this B, so now I can just reference these two now. I'll just say 1, 2. So then I can run this. So it means that it's going to give me the element that corresponds with this two, which is 20. Then I run it and it gives me that 20. So because now the most recent S, it does, so all the S's you have done, it doesn't see it. It sees the most recent one. So if you want them to be distinguished, you can now say S1, S2, S3. So you can always refer to them anytime you like. So you can access elements like this by just calling the variable name and the position of what you want, and this gives us 20. So you see key features of uh, series, it automatically aligns data by label and it supports vectorized operations. Okay. For instance, imagine that you want to print S plus 5. S is already 10, 20, 30. So S plus 5 means you're adding 5 to each element. S times 2 means you're multiplying each element by 2. S star star 2 means you're squaring each element. So if you run this now, you see S plus 5, that's 10, 20, 30 becomes 15, 25, 35. S times 2 makes 10, 20, 30 become 20, 40, 60. Then S squared, S star star 2, that square. So makes 10, 20, 30 become 100, 400, 900, like that. So you can work with it. So you can just take that series name and do an operation across without worrying so much. Then we go for data frame, which is the two-dimensional thing. So a data frame is a two-dimensional size mutable tabular structure with labeled axes, rows and columns. Okay, so now to create a data frame, of course, you can only create a data frame using in Pandas. And don't forget, Pandas had already been imported as PD. That's why you have this PD here. So without PD, you can't do that. Right. Well, here we are creating a data frame from a dictionary. A dictionary is a Python inbuilt data structure. So, and it's a key value pair, right? So the key here is name and the value will be Alice, Bob, Charlie. So now you are creating a dictionary by using a name and a list, right? Then a string and list, a name and a list of names, age and a list of ages, city and a list of cities, right? So, and imagine if I remove this PD here, nothing is going to work because data frame is a function inside of pandas. So data frame is not defined because data frame is only known inside PD. So data frame doesn't stand on its own. Okay. So once I put the PD back, then you can now get it. So now I've turned this dictionary into a Python data frame. So you can create a data frame from a dictionary. You can also create a data frame from a list of lists. Imagine now we have a data frame 2, and we just say pd.data frame. Then you now have a list of lists. So you see this. So this square brackets that also ends here is a list. Then and each thing inside it is a list. Is a list. So you have a list of lists. So pen 10, notebook 5, eraser 15. So you have those lists like that. And then we now create a column for that. We say item and quantity. And then we can have df2 to see the data frame. So it simply says that the item is pen and quantity is 10, notebook quantity is 5, eraser quantity is 15. Like you want to buy something and you need to do that. Of course, don't forget you can always customize the index. So you can also create data frames from files, right? You remember I had 3 files in my folder for this. Interestingly, you can download these folders. Just look at the description box. You click the link there. You have access to all the materials I'm using. So you can download all the folders I'm using, all the Excel, CSV, JSON files I'll be using. I'll be updating. Even my code sheet. You can, in fact, before you start watching this video, it's better you just go and download the code sheet before you start looking at it. So you see I have customer behavior, which is actually an Excel worksheet. I have city population, which is a JSON file. I have student scores, which is a CSV file. So those are the 3 files I've been working with so far. In the future, we are going to be when it comes to cleaning, we are going to be cleaning this employee record, which is not clean like that. So you can actually create data frames from files too. So and the way to do that is just like what we did in the previous lesson. So you can, so to read a CSV file, of course, df underscore CSV is just to tell us that this data frame is from a CSV file. This is just a variable name, and it can be anything. You can call it whatever you like. But the key thing is, the read CSV is actually a function inside of pandas. So if you remove pandas, you can't access it. And so read CSV tells you that the document that you follow should be a CSV file, which is student score in this case. So I just have that. And we can say print df underscore CSV here, but the print is not as neat as what you have when you just say df underscore CSV. So if I just run this, you see, it just brings out this beautiful thing because we have the list has just 50 items and numbering is from 0 to 14, and that's why everything is coming out here. So we have student ID, the name of the student, obviously they're Nigerian students, and then age, gender, grade level, math score, English score, science score, history score, art score. So that's us created. So this is now a data frame, created from a CSV file. So you can also create a data frame from an Excel file, just like the customer behavior file. So if I run this also, you see that we have so here we have 70 customers and we have 6 rows, 70 rows, 6 columns. That means 70 rows, 70 customers, right? But because it's longer than 50, it shows us the first five and the last five. So if you want to see 40, 50, you can always adjust from here by just saying df excel dot head and put it. Okay, let me demonstrate that. You can just say print, though it won't be as neat as this. So you have print and you say dot head, and then you can say maybe you want to see the first 30 customers. Okay, so you can see the first 30 customers from 0 to 29, but it's not as neat, like everything is was well arranged, right? So you can have 20, you can have 50, maximum is 50 that can show all at once. Okay. But uh but it's always neater if you just see it without the print like this. So you just have the top five and the last five. But this can give you an overview of what you have already, right? So we can also create a data frame from from JSON files. So here we have a city population of JSON file. So we have like 30 African cities with their children, youth, and adults population given. That's the JSON file we have. So all this that data, I just made them up. They are not like real data from anywhere. I just made them up myself. Okay. So now, sometimes you have a data frame already, and you want to use that data frame to perform another task without affecting the original data frame. In that case, you need to copy the data frame, right? So here we're talking about copying a data frame. So when you select a subset of a data frame, like a few rows or columns, you might accidentally change the original data if you're not careful. So the way to prevent that is use dot copy to prevent that. Okay. So for instance, so far we have so I want to use this JSON file we ended with, that's df underscore JSON, right? So this JSON file, I want a subset of that JSON file by extracting any city that has less than 50,000 children population. So from the 30 cities, right? So we see cities 45,000, 38, 52. Then we have some cities. Okay, okay. Yeah, so we have cities that have less than 50 and some above 50. So I want to extract all the cities that have greater than 50,000 population. And then I add copy here so that I can now work with that separately later. So maybe what I want to do is I want to increase all their population by 100 for whatever reason, or I just want to do some task on them. Imagine that you are an HR and you just need, so by the next following year, everybody's age just increases by one. So you just maybe you have a way of updating that automatically. So this is the kind of idea here. So if I run this now, it just shows me that Ndomasi, Tandwe, Fumvwe, and Ravila have they have children population higher than 50. And this line two means we have added 100 to those ages, to those populations. So Ndomasi had 50,000, Tandwe had 51,000, Fumvwe had 53,000, and Ravila had 51,000. But we've added 100 to each of the children population. So that's so if you don't want to tamper with the original thing, I just want to work on just a subset of the whole set. So you can use copy, to do that. So let's look at some data frame operations. So the first we are looking at will be adding, removing, or renaming columns. So if you look at that JSON file, so I'm going to be using that JSON file all the way down, So if you look at the JSON file already, let's familiarize ourselves with it. So it has 30 rows and one, two, three, 4 columns, right? 30 rows and 4 columns. You don't count the index, right? So it starts from Zalanga, Kwevura, Ndomasi, Shwene, Lumora, Bazemba, Yorendu, Gavani, and all of that with children population, youth population, and adult population, right? So just familiarize yourself with that. So if you want to add a new column, for instance, here we don't have total population. So I know total population with just the addition of all the children, youth, and adults population. So if you want to add a new population to that now, so we can just add a new column. We say df underscore JSON. That's the original document. Then we now have total population, which did not exist before. And to get the total population, what I'm going to do is I just want to say df JSON children population plus df JSON youth population plus df JSON underscore JSON adult population, and then I call the df.json, then I see what it looks like. So if I run this now, you see we have a new column added. That's this total population, which did not exist up here before now. So now we have a 30 by 5 table, right? So 30 rows, one, two, three, four, five uh, columns, right? So Zalanga total population is the addition of all this. So we have 262,000. Wevura, we have this, Indomasi, and so on and so forth. So we have added a new column. So what if we want to remove that same column? So to add a new column, we just put the new column name and whatever we want the column to have, right? We have that. So here I've got the new column by adding the previous three. What if you want to remove a column? The keyword is drop, okay? So drop is the keyword if you need to remove a column. Let me put that in front here. So I say underscore underscore, then I just say dot, that should be dot drop like this. So that's the keyword for removing a column. So we just added total population to that df.json.drop df underscore json now. So now I want to remove the total population again. So by the time we call the df.json, but because of this first line, the total population would have gone. So I just click and you see the total population is done, it's gone. Now we have our original df.json again. So total population here is now gone. So you can remove. I could have removed any of the other columns, but because we added that, we can also remove it. Now, so far you see the city, we have city, children population, youth population, adult population. What if we want to rename something? Like I want to rename the city. Instead of city, I want to call it city name. Okay. So I now say df.json dot rename. So the keyword for this is rename. So this, then I have rename, that's dot rename in brackets. So this goes. So we have rename. So df.json.rename. So what column do you want to rename? We want to rename column city to become city name. So you can also rename others if you like. So the new df.json now has the city, instead of city, you now have city name. So we have renamed that. Okay, having done that, can we talk about sorting rows? Sometimes if you look at the list is not in alphabetical order. So imagine it starts with Z, in fact, Zalanga, Wevura, and Domasi. And towards the end, you now have Ravila, Chiboka, Zikwava, Inyomera, and the rest of them. So what if you want to sort all of that? For instance, so what I'm going to do, I want to do two things here. I want to sort the rows and reset the index to start numbering from 1. It's numbering from 0 here to 20, now making 30. But I want to actually have it to be from 1 to 30 in this case. So now I want to sort the data frame. No in place is equal to true. So we can assign a new variable, right? So we say df. So this no in place equals true that we've always been having is no longer here because we want to have a new variable name. So now, what we had before was df underscore JSON. Now I want to have df underscore JSON underscore S, right? So, and that is, so, but this df underscore JSON underscore S is going to come from me sorting the original df underscore JSON. So I want to sort the values by city name. That's in alphabetical order now. All right. Then after doing that in line 5, I want to reset the index and start numbering from 1. So line 5 resets the index. So we have df, underscore JSON dot underscore S dot reset underscore index. And then we drop. So we drop true. We drop the index before and in place true because we now have we are doing we are working with this df underscore JSON underscore S. So in line 6 now we have df underscore JSON under S dot index plus equals 1. So we want to update each index 0 plus 1, that's 1, 1 plus 1, 2, and so on and so forth. Instead of having 0 to 29, we now have 1 to 30. And then by the time we display the sorted data frame, we see that's what line 9 gives us. So you see, we now have everything arranged in alphabetical order, which is more, I mean, once things are arranged in alphabetical order, you can easily trace things. So we now have Bazimba coming first, followed by Chiboka, then Fumvwe, Gavani, Gorensi, Jivanda, Kalumi, Kwazira, Kwevura, Lumora, Luendu, and all of this. These cities don't exist. I just made them of Vimbasa and the rest. Okay. So now everything is sorted in alphabetical order, right? So with that in place now, what if we want to sort rows and reset the index? Now we don't care whether it's, we just want to maintain, we just want to sort the rows and reset the index. That means we want to maintain our 0 to 29 because that's what Python is used to avoid confusion. So now instead of, this other one, we call it df underscore JSON underscore s. Now I want to call it df underscore JSON underscore sort, right? Because I want to do a lot with this after now, so that's why I'm naming it this. So by we are still sorting values by city name. So it means you can also sort by population. Okay, let me do this first. So if I run this now, so normally the essence of what is happening here. So if I don't do this reset, if I just comment this out and I don't do this reset, look at what is going to happen. If I run this now, you see it has been sorted in alphabetical order, but it brings the normal former index 5, 28, 21, and it's all scattered. But you want something to be numbered. And that is why I have to uncomment this so that it can reset the index. So if I do that reset now, so Bazimba is now 0 and it goes all of the way down to Zikwava, which is number 29 now. Okay. So now, what if we want to sort by adult population? So adult population. So you want to sort by, maybe there's something you want to give to the adults in the country and you want to sort by the adult population. So if I click now, so you see that it starts from Shwene, the one that has the lowest number of adults, okay, to Gavani with 160,000 adults. So Shirene has 95,000 adults, while Gavani has 160,000 adults. So maybe you have a plan for them for the adult population. So this can help you to know what you would need to do for each of them based on the population in that place. So all of this can be some kind of decision making thing. But I actually want to sort in alphabetical order like before. So I use city name. I use city name, and then now so city name is now sorted in alphabetical order. So what about selecting rows and columns, right? So I'm going to use this df underscore JSON underscore sort for every other thing I'm going to do. So look at this table, Bazimba to Zikwava with children population, youth population, and adult population. So selecting rows and columns. So if you want to select any row, like you want to select the row for city name, for instance, so so if you run this, it just extracts all the city names. Maybe you just need the city names for whatever reason. So you just extract all that from Bazimba to Zikwava. And then maybe I want to retrieve city name together with adult population for each of the city. Maybe we have a plan for them. So I just click on that. So it gives me the city names and the adult population for those cities, right? If you want youth population or children population, you can do the same in case you have something for them. So we can also select rows by position, okay? So if you selecting row by position, use I lock, right? So if you say df underscore JSON underscore, so that's the file name, dot ilock 0. So it means I need the first row. So I need the first row of this data. So the first row, that's Bazimba 34,000, 70,000, 110,000 for the three populations. So I have this now. Yeah, so you just extract that and it now brings it out in that vertical format. What if I say I want second row, third column, second row, third column? This 1, 2 means second row. Since Python starts from counting from 0. So I need second row, third column. So second row is Chiboka and all this. Third column, this is row 1, row 2, column 0, 1, 2, 3. So second row, okay, second row, column 0, column 1, column 2. So that's third column is 74,000, right? So 1, 2, 3, because the counting starts from 0. So it means that result is going to be 74,000. So I click on this now, it gives 74,000. So also, what if I want rows 1 and 2? Because this is 0, 1, we don't get to 2. Once we have to go up like this with this full colon, it stops short, a step short, like we've learned in previous lessons. So this just gives him Bazimba and Chiboka only for the rows. So that's how we do rows. So, but you can also select rows by label, right? So here we select rows by position. That I, tells us about the positioning. But here we can also select the rows by label. So if I run this now, so label will match up with the label here is more like the same thing with the iLock one. But then when you come to okay, we also did 02 before, right? We did 02 for this. So if I jump to that 02, in fact, let me cut this out and bring it under. Yeah, let's bring it under here. This can go, I do DD. Okay, so we also did 02 here before. Um, maybe I should even do, let me match everything and see what happens. So I have this now for iLock after before 02, in fact. So here, I bring this here, I pull this, then I need just look for this. Let's see what the difference looks like. Okay. Okay, DF underscore JSON underscore sort. Okay, it's not working for 1, 2. Okay, it doesn't work here. Okay, so we leave that out. Okay, I escape and delete. Good. So 02, it gives us something. So while this one gave us, this now will include row 2. It includes row 2, unlike iLock. For iLock, row 2 is excluded because it's about position. But this one is about label. So as far as label is concerned, anything that carries that label will be outputted. So while iLock excludes Fumvwe, lock includes Fumvwe because it's about label, not position. So for position, you count from 0 and you stop a step short of the higher number, right? So if you have df underscore JSON lock 21 population, so it means value at row 21 and column under youth population. So if I click on this now, row 21 youth population. So 21 youth population, that's I think that should be, 21 there should mean a step more since we started counting from 0. So row 21 should actually be Tavuma, Tavuma 94,000. Okay. So that's why we have that. So we have Tavuma. No, Tavuma, no, row 21 youth population. I think, let me see, 21 youth population. 21 youth population. Youth population is the middle one, right? 21 youth population. Is it 93,000? Let's see. 93, it's 96,000. Row 21, youth population, 96,000. 21. Where's that coming from? Row 21, youth population. Okay, let me see again. Did I use the right file? Aha, that's the trouble. So I've been using sort. That's why I'm confused. So there was a sort before now. So let's use I didn't add the sort. So the file name matter. Yeah, row 21, youth population. Yes. 21 youth population. Yeah, exactly. So that's 93,000 now. So see the file name, the naming is really important here to avoid confusion. All right. So you see that LOC is label based. So it's about the label. Once it carries the number, it will be outputted. But iLock is integer based. So if it's so you do it based on the counts and then you stop short of the higher number like usual in Python. So let's talk about conditional selection. So what if I want the list of all cities with adult population greater than 135,000. That's what I've done here. So I said df underscore JSON underscore sort into df underscore JSON underscore sort, all adult population in df underscore JSON underscore sort. So that is bigger than 135,000. That's what I want now. So I just click on this. It gives me Fumwe, Gavani, Kwazira, Lumora, Mwirika, and so on and so forth until we get to Zikwava. So what if I want to do something lower? Say I do this now, and then I want children population, children, children population equals 50,000. I mean, I'm just trying to see if that works. Children population is equal to 50,000. Okay, is there anything like that? We don't have any, no group has 50,000. Okay, so I think we had 51,000. Let's see, maybe only one. children population. Okay, maybe you meant, oh, okay. Yeah, it's a logical kind of statement. So that's so double equality. Children. Okay, I said children. So it should be children. Yeah. So children. So if you spell it wrongly, it doesn't work. So here we have children population exactly 51,000. So Ravila and Sandwe has population of 51,000 children, like that. So this is where children population is equal to 50,000. 50,000, like that. So that's what we have. Ravila and Tandwe meets fits that bill. So let's see another situation. Let's say now, what we did up here was adult population. Let's do something for youth population. So maybe we want youth population. Generally the youth population is 96. Okay, let's say we need youth population less than less than or equal to 96,000. Okay. So that's youth population, rows where youth population is equal to, is less than or equal to 96,000. That's what we're going to have here. Okay. So see them. Uh, so all of the ones less than, so we have them here. Oh, it's like everything matches, right? Maybe let's say less than or equal to um less than or equal to 50,000. Let's see, does that work? Okay, do you have fewer numbers now? We are talking about youth. Oh, it's children I still have there. I want youth population, sorry. Youth youth population less than 50,000. Okay, we have a few. Youth population. Oh, I've run another thing, sorry. Youth population less than 50,000. None. Okay. What about 150,000? Yeah, we have some. We have some youth population less than 150,000. Okay, so let's say less than 96,000. 96,000. Okay, so youth population 70. Okay, let me say less than 70,000. Less than 70,000. And this is also 70,000. 70,000. Okay, so we have Bazimba, Yomera, Rukongo, Chwene, and Ubwanga. Okay, now the last part of this lesson, if you look at my folder, now we've learned how to import data, like you have Excel, CSV, and JSON file, and you import into this place. What if you want to export data, right? So now I have got that data sorted. So this DJ sort that I've done in alphabetical order, this particular one from Bazimba to Zikwava, and I just want to write it to CSV. I want to write it to Excel. I want to write it to output. You know, when we're reading, right? We said whatever uh, PD dot read underscore CSV, PD dot read underscore uh, XLSX, PDF dot read underscore JSON. But here we want to export. So now we want to write to. So we have keywords like to CSV, to Excel, to JSON, and PD is not needed here. That the pandas is not needed. The pandas name is not needed here, you know. So, and guess what? Output underscore CV, output underscore Excel, output underscore JSON. I don't have anything like that in my folder. You know, this is the folder where this is the data, this is the code sheet I'm working with now. So you have to make sure all the data sets you want to use, make sure they are in one folder. Make sure your Jupyter Notebook code sheet is also in the same place so that everything works in that same space. Okay, so imagine that you have this here now. So I don't have anything output here. So watch what's going to happen as I'm going to write to each of them. So I'm going to write. So I want to now export data sets to CSV. So my JSON, that JSON underscore sort, which I've ordered from A to Z. I now want to write to CSV. So I just come here and I just enter. I run it. Once I run it, a number appears there. So it means you won't see anything. But once the number shows and it doesn't show error, it means an output.csv file has been is now here. So you can see output underscore CSV. So if you look around, there's no output underscore Excel, there's no output underscore JSON. So I go back and I do the one for Excel. I click on this. Now the number has shown and there's no error. It means I have created that Excel file. So you see output underscore Excel file. You can open it and see what it looks like. So you see the city name is there, the children population is there, the youth population is there, the adult population is there. So with all the numbers, so you can centralize if you like, just to make it neater. Okay, so like you have all of this. Then I can go back and so you can see there's no JSON here yet, right? There's no output underscore JSON. There's nothing like that here, or output.json. So I come back here now and I just run outputs.json. So once the number shows and it shows no error, then you can go back and the JSON file is here. So you can click it, it opens, you can open that in Notepad, you know, and you see all of it. So name, city name, and all the rest like that. Children population, adult population, blah blah blah. So you have all of them like this. Okay. So I go back here. Yeah, we are done now. Thanks for listening. Um, let me know in the comment section how helpful this has been for you. And if you have a question, feel free to ask. If you need me to teach a topic or solve a problem, you have a data set you want us to analyze, feel very free. Let's see how that works. All right. So if you have not subscribed to the channel, please go ahead and subscribe because you'll be missing a lot. There's a lot more coming. Um, and be sure to hit the notification bell so you can always get alerted each time a new video is released. Then be sure to like and share so that more people can have access to this great content. Till I come your way again, keep doing data right. Bye.